Hey, welcome to Math Mini Lessons. I'm Sarah, and in this lesson, we're going to look at two-way data tables. We're going to look at all this data and information, and we're going to go back to some percentages, which was early middle school work. Take a moment to look at our look-fors, and we'll get started with the first model. Let's look at this two-way data table. And what it is a very nice organized way of looking at two important pieces of information. One, we're looking at the ages in this table of people who play bingo. And two, we're looking at the differences between those who play and those who don't. Now, this table also gives us an extra bit of information by giving us the totals for each one. For example, in terms of the number of people younger than 30, you can take those who play bingo and those who do not and add them up together to get a total of 175. So you can see they've done the same addition here to make 12, and they've done the same addition here to get 187. Some tables will not have that. So if some tables do not have this information, you can just add yourself and add a total part to it if need be, a column for that. And there's also a row down here for totals, which again, they're just adding these two together to get these numbers, adding these two together, adding these two together. Now, totals are going to be really important because our tables and our data information is going to ask us about percentages. So we will need totals in order to do a percentage, which is a part to whole relationship. So we're going to need that. On top of that, we're also going to have our calculators out to figure out percentages. So let's jump into the first one. What is the total number of people younger than 30? So this is just a throwaway question. You want to look at the row younger than 30, and if they didn't have a total, we can just add these together to get 175. They also just gave it to us. So 175 people. And now they want to ask what percentage of them play bingo? What percentage of those people under 30 play bingo? Now, I will go to my row. So I'm going here and I will look here to find this number. So I want younger than 30 and plays bingo, and that's 25. So I'm going to write that ratio as 25 out of 175 play bingo. And to do this as a percentage, when you were younger, you had to use math to make a ratio table and do n over 100 and cross multiply. We're not going to do that right now in 8th grade. Instead, what I want you to do is on your calculators, you're going to do 25 divided by 175. Okay, so 25 divided by 175 is going to give me 0.142. I'm going to change that into a percent by taking this decimal and moving it over 2 times. And that is going to give me 14.2%. Okay, so we're going to use our tools carefully to just figure out percentage. And let's go to the next one. And this time they're asking, what is the total number of 30-year-olds who were surveyed? So 30 or older. So again, I'm looking at the table, I'm going to the row 30 or older, and I want the total number. So I want those who played bingo and those who did not. So I have 12. And now I want to know what percentage of them play bingo. So out of everyone in this row, how many play bingo? Only 10. So I'm going to represent that. So 10 out of 12. So again, on my calculator, I'm going to do 10 divided by 12. And you're going to get 0.83. It's actually 33333. Again, you're going to move your decimal over once and twice, so you can turn that into a percentage, and you're going to get 83.3%. So notice I'm doing this on purpose. I'm having us look for the total first and then finding the one we want, just to get us into that habit. Sometimes they're just going to ask for the percentage, so you're going to have to find a part out of the total, the part to whole relationship. All right, and let's look at the last one. We want to know the total number of people surveyed. So everyone surveyed, and I look at my table and I see there's 187 people. And I want to know how many of them do not play bingo. So out of everyone, how many do not play bingo? So I would look over here. So if I didn't have a total, I would add these two together to get 152. So we'll represent that 152 out of 187. You know what we're going to do. We're going to divide. And if you can't remember which one to divide by, just remember it's like a book. You read from top to bottom. So 152 divided by 187 is equal to 0.812. Move that decimal 2 times, you get 81.2%. And that's the practice we're going to do today, Math Marbles. We're going to practice finding percentages and finding the information that we want, the stats we want from the two-way data table. So this just requires being careful and understanding where your information is, since it is nicely organized on the graph. Hit pause and jot this down into your notes. Let's look at this multiple choice. Answered only 3 choices. A reporter in a small town polled some residents and asked them if they were in favor of increasing the minimum wage or against it. After the survey, the data showed 58 younger adults and 64 older adults were questioned. So that's telling us about the totals. The answer included 70 people who were in favor of the increase and 52 who were against the increase. Which table correctly represents this data? So we're going to look at each data piece one by one to see which are accurate. And I'm going to, again, annotate. Here are my totals. These are the people who were for and against. Okay, these are people for, those are the people who were against. So in the first one, I see that 35 young adults were for and 26 were against, but I can't see the total. So let's figure out our totals. And if I add 35 plus 35, this will tell me that 70 people were for the increase and 52 people were against the increase. That seems to match. Let's see, 70 were in favor. That's what we're looking for. So that's true. 52 were against, and that is true. Let's see if our other totals are correct. They surveyed 58 people, so that means we're going to add in this direction as well. So I'm going to use my calculator for this. 35 plus 26 is equal to 61. So 61 younger people, and in the other direction, 35 plus 26 would also be 61. So this data doesn't match, where we are looking for 58 young adults and 64 older. So this part is right, these are wrong. Okay, so we're going to do the same thing with E. We're going to add going down on the bottom part, and I'm going to use again my calculator for speed. So I'm going to add 42 and 28. I get 70. So that's correct. And 16 plus 36 is 52. So those two parts are correct. Let's see if I get the other two numbers that we're looking for. All right, 42 plus 16 is equal to 58. 58 younger people, so far so good. And 28 plus 36 is 64. So these are the numbers we're actually looking for. So let's just make sure, let's look at C. And you can see how distractors, if we find party information, it looks like we're right in A, but we add all of them together. Let's do the same thing for C. And we have 42 and 28. So those were the same numbers we had before, so 70. 16 and 32, so 52. So look at how our bottom totals are all the same. Well, let's do our top parts. 28 plus 36 is equal to 64. And 42 plus 16 is equal to 58. So the challenge is, those are the two numbers we're looking for, but we wanted 58 younger, and this tells us 64 younger. So they reversed these two numbers. So this is incorrect. B is our correct answer. And that was a big takeaway. I wanted you to see how we can get a two-way frequency table that may not have totals, and we can figure out those totals just by adding. Let's hit pause and jot this one down into our notes. And I'm going to add, we can calculate totals for two-way tables, because some tables will not have that information. That's it for now. That was our guided practice. Hit pause, jot this into your notes, and let's get into practice with these tables.